All right, in this lesson, we're going to use logs to model some data. Okay, so we have this little table, and remember that the independent variables, the independent values increase proportionally while the dependent or the y values, the outputs, increase at a constant rate. So those are your equal length output intervals. All right, so if we look at this table here, the outputs are increasing by 2 each time. So we have equal length output intervals. And the inputs, these are now, you can see that they're multiplying by 3. So proportional by a factor of 3. Okay, so we recognize that that's a log relationship. Okay, so down below here, we can create log equations, log functions in either one of these forms, depending on the base you want to use. So y equals a plus b, and then ln of x, or log x, log base 10, where a and b are constants, b can't be 0. Okay, so for given data, it says selected values of a log function are given. This is the model. Use the given data to write 2 equations. We've done this before. So this is the model we're using. We're going to input into our x and our L of x. So 3 equals a plus b ln of 2. And 7 equals a plus b ln of 5. So I'm just using both pairs for your x and your ln of x. And then finding the values of a and b, well, we can do this. If we take one of them, I'm going to isolate a, so it'll be 3 minus b ln of 2. Substitute this into a of that equation, so we'll have 7 equals 3 minus b ln of 2 plus b ln of 5. Well, I'm going to move the 3 over. I'm just going to put the order backwards so that subtraction's in the middle here. So 4 equals b ln of 5 minus b ln of 2. I can factor out b so that it is by itself. Remember, if I have 2 logs being subtracted, it's the same as ln of 5 divided by 2. And I can divide both sides by that natural log. B is then ln of 5 over 2 divided into 4. We can actually figure out what that value is. And we get approximately 4.3654, always rounding 4 decimal places. Now going back up and finding a, put that value in. So I'm going to take, I'm just going to say answer, store that into, call it x. And now if I do 3 minus x ln of 2, I should get what a is. Negative 0.0259. Okay, so you can find a and b. And depending on if you have to show work or not, you could always put your 2 equations in here and ideally have it solve it. All right, for the next one, we got end of the school year, classroom gets warm, don't you know it? As the number of students increases, so does the temperature. So we have students on top, temperature on the bottom there. Find the logarithmic regression. So take a minute, let's put this into our regression app, please. All right, so we can now graph it. You can see it looks logarithmic, put that regression in. So we haven't used this yet, but it is down here, logarithmic regression. It's in the same format of what they gave us for t. So we can calculate that. There's our equation. Okay, we're going to write it using the right notation. So it's T of X equals A was 65, B was 2.8854, ln of X. According to the model, what is the temperature if there are 35 students? So we're going to put in 35 and find out what T is. So we can go back here, predict Y given X. And 75. So about 75 degrees. Always give the full decimal and then round it if you want to. That way both answers are there depending on what we're looking for. And then according to the model, how many students are there if the temperature reaches 85? So that's your Y now. And find your X. Whew, 1,024. That is way too many. We don't want that many in our class. All right, last one here. We've got Mr. Stiller wants to save for a new Lamborghini. Good for him. He currently has 50,000. He's continuously, he will need 300,000 in total. If he leaves his account for 12 years, not adding anything, what interest rate would he need to achieve? So we're using PERT because of the continuously. So he starts with 50,000. We don't know the rate, but we do know it's 12 years. And he needs 300,000. So we're going to solve this now. Divide by the 50,000. Now we're going to convert to a log, so that's ln because it's log base e of 6 equals 12r. Divide by 12. So ln of 6 divided by 12, 0.1493. It says what's the rate? So this is the decimal. You got to multiply by 100. So 14.93% or about 15%.